Hello everyone, welcome to the second video on two-dimensional random variable on continuous case. This video will concentrate on estimating the value of a marginal density function of the random variable x and y from the joint PDF f of x comma y. We will recollect the formula required. The marginal density function of x, which is the MDF of x, is given by the formula f of x is integral minus infinity to infinity f of x comma y dy, and the marginal density function of the random variable y is given by f of y, which is integral from minus infinity to infinity f of x comma y dx. We need to keep in mind for as a shortcut that when we want with respect to x, opposite pole attract each other. Therefore, when it is x, integrate with respect to y. And when it is going to be with respect to y, you will have to integrate with respect to the variable x. Now we will try to quickly fix this to a problem and estimate the marginal density function of x and y. Let us find the marginal density function of the random variable x and y for the given function f of x comma y, given as 2 by 7 times of 2x plus 5y, where your x varies between 0 to 1 and y varies between 0 to 1. We will recollect the formula required. The marginal density function of the random variable x, which is given as f of x, is integral f of x comma y with respect to the variable dy, because opposite poles attract each other. Now this is going to be integral of the function f of x comma y has been defined or given to us as 2 by 7 times of 2x plus 5y. I have to integrate with respect to y and the range of y. Y varies between 0 to 1. So my integration can now be started. So this gives me 2 by 7 times of 2 with respect to y. 2 is a constant, x is a constant, the variable on integration is y, plus second term 5 times 5 is a constant, y on integration gives you y square divided by 2 between the limits 0 to 1. So this gives me 2 by 7 times of 2. Now which variable has to take the limit 1 and 0? You will have to keep in mind, I want a function of x, I need to eliminate y. So y takes the value 1 and y takes the lower limit 0. Don't apply it in the opposite way round, because in which case what will happen is you will be left out with a y rather than the function of x which is desired. So apply the limit properly for the required variable. So y is getting integrated, so apply the limit for the variable y. So keep your x as such, y takes the upper limit 1 minus the lower limit 0, plus 5 by 2 times of y square is going to be 1 square minus 0 square is going to be 0. So my function f of x is going to be equal to 2 by 7 times of 2x plus 5 by 2. We can notice over here that we entirely have a function of the variable x plus that of a constant, and our second variable called as y has been totally eliminated from over here. But a point to note is that this doesn't completely define the function, as we haven't specified the range for the variable x. What does mean the range of the variable x? The boundary to where my x can take its value from. And I know that from the given question, x can take the value between 0 less than x less than 1. Attach it, otherwise the function f of x becomes meaningless without a range. Now we are defining the marginal density function of x. Next, let us move on to find out the marginal density function of the random variable y. So this is given by f of y, which is integral f of x comma y with respect to the variable dx, because we know that if it is y, you will have to integrate with the opposite variable called as x. So this gives us integral. The function to be integrated is 2 by 7 2x plus 5y. 2 by 7 times of 2x plus 5y. Integrate with respect to x. Now the limit for my x. What is going to be the limit of x? Limit of x has been given as 0 to 1. So integrate it between 0 to 1. So 2 by 7 is a constant. Keep it outside. With respect to x, 2 is a constant. X on integration gives you x square divided by 2. And 5 is a constant. Y is a constant. Then the constant on integration gives you the variable x. Now apply the limit between 0 to 1. So this gives me 2 by 7 times of 2 can be cancelled off. Upper limit is going to be 1 square minus 0. And 5y is the constant. Now x takes the value 1 minus 0. So now we have the value of our function f of y to be equal to 2 by 7 times of 1 plus 5y. Again, we notice that we have been got with a function that is going to be entirely dealing with the variable y and the constant alone, and the second variable called as x has been totally eliminated from over here. We can complete the definition of this f of y by including the range of the variable y, and we know that the y values between your 0 to 1. So you can complete the marginal density function of y as 2 by 7 1 plus 5y for 0 less than y less than or equal to 1. We move on to our next problem where my f of x comma y is 8xy by 9 for 1 less than x less than y less than 2 and is 0 elsewhere. We'll have to find the marginal density function of x and y. Now the only difference between the first and the second problem is that over here the range has been given like a train. It is going to be a range of ranges 1 less than x and x is less than y and y is less than 2. Now we need to keep in mind in which case what will be the limit taken by your value x. X has the lower limit as 1 and x has the upper limit of y. So my x will vary between 1 to y. Now coming to the second variable, what is going to be happening with that of y? Y has the lower limit of x and y has the upper limit of 2. So my y will vary between x to 2. So if we keep this in mind, then the problem is going to be much similar to that of the one which we have already noticed in the first problem. So we will find out the marginal density function of the random variable x, which is going to be your f of x. So integral f of x comma y, integral with respect to the opposite pole, which is going to be y. Now I know that my y varies between x and 2. So y varies between x and 2. Lower limit is x, upper limit is 2. So I have this to be y varying between x and 2. The function to be integrated is 8 by 9 times of xy with respect to dy. With respect to dy, 8 by 9 is a constant, x is a constant, y dy on integration gives you y square divided by 2 between the limits 2 and x. So now this 2 can go off in this 4 times, leaving you with 4x by 9 times of, apply the value for your upper limit, y square makes it as 4 minus lower limit is going to be x square. So I have now an entire function of x and that of a constant involved, and my second variable y has been eliminated totally from my function. Now to complete this marginal density function, I need the range of x, and I know that the range of x is 1 less than x less than y. But in case when I am going to substitute the upper limit of y over here in this variable x, now I'll be getting a function of y that has to be avoided. So go for the extended region of y. Where does your y vary till? It varies till 2. So x can also vary till 2, which means that I can strike off this y and I can write it as 1 less than x less than 2. So now this defines the boundary for my variable x. So my function mdf of x is 4x by 9 4 minus x square for 1 less than x less than 2. Now let us move on to estimate the marginal density function of y. So what is going to be the marginal density function of the random variable y? It is going to be f of y and is given as integral f of x comma y with respect to the opposite pole or attract each other. So it is going to be x. Now how about my limit of x? I know that my x varies between 1 to y. My x varies between 1 to y. So my limit of integration is x starts from 1 and is integrated till y. And the function to be integrated has been given to us as f of x comma y. Joint function is 8 by 9 times of xy dx. With respect to the variable x, 8 by 9 is a constant, y is a constant. X on integration gives you x square divided by 2. Apply the upper limit minus the lower limit. Now 2 can be cancelled off with this 8 4 times. So leaving you with 4y by 9, and this gives you upper limit is y square minus lower limit is going to be 1 square. So my f of y is going to be 4y by 9 valid for y square minus 1. And now to complete the function, I will have to write the validity for my y. Where is going to be the validity for your y? Y varies between x to 2. So my y varies between x to 2. And now when I am going to apply the lower limit for my y here, I will have a function of x. So to avoid this, I go for the extended limit of x. What is the extended limit of x? It starts with 1. So my y can take the value till 1. So now eliminating this x, I write it as 1 less than y less than 2. So my function f of y is going to be defined for 4y by 9 y square minus 1 for 1 less than y less than 2. So if you keep these things in mind, like when it is going to be an extended function, go for the constant value when you finally define the range of it. Then you will be easily able to define the marginal density functions of your random variable x and y. Keep in mind, opposite pole attract each other. So y has to be integrated with respect to x has to be integrated with respect to y. Thank you.